Okay, 9.7 physics course revision. Define power and give its unit. Power is the work divided by the time. And the unit of power is watts. Okay, W. Uh, what did he say? A car is traveling at 30 meters per second on a level road against a constant resistance of 450 newtons. How much work does the car engine do in 10 seconds? Okay, we know work is the force times the distance. Okay, can we find the distance if it's going for 30 meters per second, 10 seconds? Yes, we can, right? And we know x equals vt. So x equals 30 times t equals 300 meters. Okay, so work equals, it's a resistance force, so it's negative 450. Okay, so negative 450 times 300, and you get uh, 13,500. Okay, okay, they kept it positive. Okay, yeah, I guess keep it positive. Yeah, you know what? Don't make it negative. Just keep it positive. So it's 13,500 joules. Okay, is it 13,500? Is that correct? No, 135,000. I don't know the zero. Okay, what is the power? Power is work divided by the time. So it's this work divided by this time. So you're gonna get 135,000 divided by 10. You get 13,500. They put it in kilowatts, so you just divide by 1,000, 13.5 kilowatts. Okay, find the power. Uh, the time always has to be in seconds, okay? Find the power generated by a boy of mass 50 if he runs up a flight of 50 steps in 25 seconds, knowing that the height of each step is 15 centimeters. Okay, so it's work divided by the time, and we know that the work done is actually equal to uh, the potential energy gained, right? So we can do mgh, so 50 times 10 times the height. If each step is 15 and we have 50 steps, so 15 centimeters is 0.15 meters. So 50 times 0.15. Okay, and you're gonna get how much do you get for the work? 365. Ah, they use G as 9.8. They use G as 9.8. Okay, if it's not specified, you can use 10 or 9.8, doesn't matter. Okay, so times 9.8. Okay, uh, yeah, so you get 3675 joules. And we know it's work divided by the time, so divide this by 25, and you get 147. Okay, question 20. A kilowatt hour is the energy released on an object that has a power of 1 kilowatt, works for a time of 1 hour. How many joules is this? So we know power equals work divided by time. So can we find the work? Okay, power is 1 kilowatt, which is 1000 watts. We can't work with kilo. Okay, so 1000 watts, right, is my power, equals the work divided by the time. The time is 1 hour. In seconds, that's 3,600 seconds. So 3,600. So how can I find the work? It's cross multiply 1000 times 3,600, and you should get you get 3.6 times 10 to the power of 6. And they put it in megajoules, so they just divide it by a million. Okay, question 21. A mass m slides from rest down a smooth incline of length L, moving down a height h. Okay, length L, moving down a height h. Okay, find a mathematical relation between L, h, and the angle of inclination. Okay, so this is obviously a right angle triangle, yeah? Okay, and between the angle of inclination would be this, is called alpha. Okay, this is L. Okay, how would you find, what would the relation be here? We have opposite, we have hypotenuse, opposite, and we have hypotenuse. Okay, so that means sine alpha equals the opposite side h over L, right? So we could say L sine alpha, if you just cross multiply, equals h. Okay, this doesn't come as yani. Okay, the loss of gravitational potential energy in terms of L. The loss of gravitational potential is minus mgh, because loss yani negative and gravitational potential is mgh. We said h is L sine alpha, so we can just replace h with L sine alpha. It'll be minus mg L sine alpha. Okay, the bob of a pendulum swings between a point P on the extreme right and a point Q on the extreme left. So point P on the extreme right and point Q on the extreme left. R is the midpoint of the path of the bob, so we could say R is over here. Which of the following are true? The kinetic energy of the bob is 0 at R. That's not true. So the first one is not true. The kinetic energy is 0 at R. Actually, if it's swinging, what does the bob do? It stops at Q and then starts swinging back, and then it stops at P and then starts swinging back. So when does it have 0 kinetic energy? When it stops, right? When the velocity is 0. So it will have 0 kinetic energy at Q and at P. Okay, so is it 0 at R? No, it actually has the maximum. Its highest speed is at R. Okay, well, yeah, because it said it's the midpoint, it's the highest at the midpoint. At the point between P and R, the bob possesses both potential and kinetic. So I could say between P and R over here, it has potential and kinetic. So it's at motion and it's raised to a height. So does it have potential? Since it's raised to a height, yes. And since it's at motion, it has kinetic. So yes. The potential energy of the bob is maximum at P. It has the highest potential energy at P. It's the highest height, yeah? When does it have the highest potential energy? When it's the highest height. Since it's the highest height, so it has potential energy. Then question 23, a car traveling at velocity 30 meters per second, okay, is on a level road against a constant resistance of 450. How much work does the car engine do in 10 seconds? So how much work? Work equals, I think we just solved this actually. Yeah, the force is 450 times, the distance is 30 times 10 because x equals velocity times time, right? So 300, 30 times 10, 300. Okay, so this is going to be 135,000. And the time, we want power, right? We want the power. Power is work divided by time, which is going to be 135,000 divided by 10, which is 13,500 watts. Okay, watts. That's it for this. Good luck tomorrow in your physics final. Thank you so much for watching.